In section 3.3, we're going to be talking about power functions and polynomial functions. So power functions are indicated to be one term. You have x is your base, and then c is an exponent, and c is going to be a constant number. So the first thing you're asked to do with these is to find the degree. So I've written down a few here for us to look at. So I have negative 4x to the sixth. So the degree of this is 6. All right, the next one we have 4. So you can imagine that this is like x to the 0 power. Okay, so it's a constant. And when we have a constant, the degree of a constant is 0 because there's no variable. The next one, we have a degree of 8. So each one of those just has one variable. Now, our next one has one term, but 2 variables. So x to the 9th power, and then there is this imaginary 1 with the y. So that term has a degree of 10. You add the 2 exponents. All right, the degree of a polynomial, so we're moving away from power functions, but into a polynomial, is the term with the highest degree. So of the ones that we just did, the list is just written out so that they're added and subtracted. So the degree of this entire thing is 10. All right, so another thing that they're going to ask you to do is talk about not just the degree, but you're also going to have to talk about the leading coefficient. So when you start doing this, the first thing you need to do is make sure that it's in descending order. So negative x to the 6th minus 2x to the 5th plus 3x cubed, and then you have plus 1 on the end. All right, so the degree of this one, if I did them individually, then I look for the biggest one. So the first term has a degree of 6. The second term has a degree of 5. The third one has a degree of 3. And the last one has a degree of 0 because it is a constant. So the degree is the degree that is biggest, so that would be a 6. Now, the leading coefficient, once they're in descending order, would be this very front number. So that's going to be a negative 1. I think there's also a question maybe that asks you about what is the constant. So this will be the term that has no variable with it. So my constant would be the number 1 at the end. So there's a correlation between the degree of a polynomial and the maximum number of real zeros. So for example, in that last one that we just did, there will be at most 6 times that it hits the x-axis. It doesn't mean that it's guaranteed that it will, it just means that it can be. So if you take that degree and you subtract 1 from it, that gives you the maximum number of turning points that it can possibly have. And turning points is another way of saying maximums and minimums. So the next thing we're going to talk about is long-run behavior. And what this wants to know is as my x's get bigger and bigger and bigger, or they get smaller and smaller and smaller, what does the function itself do? So I have color-coded these so that if we have an even degreed polynomial, so obviously that's going to be 2, 4, 6, 8 or bigger, all right, and your leading coefficient is a positive, then both ends will go up. And I've said here to think of the graph of x squared because that's the simplest version of this that we could have, an even degree with a leading coefficient that's positive. All right, so the biggest thing with these is that if it's even, they're going to go in the same direction. Okay, so if it's positive, then they're both going to go up. If it's negative, they're both going to go down. So you can think of negative x squared. So that reflects it over the x-axis. So in that case, they would both go down. Now, the way we write this is to say as x approaches negative infinity, so my x is going in this direction, then my y value, or my f of x, is going up to this positive infinity up here. So as x goes to negative infinity, f of x or y is also going to go up to positive infinity. Now again, if we talk about x going toward positive infinity, that means as my x's are going off in this direction, the function itself is going up. So we write this as f of x goes to positive infinity. So you have to make that relationship make sense, that again over here as x's are going toward negative infinity, then in this case, if your leading coefficient is negative, then my function will be going down to negative infinity. And then similarly, if x is going off to positive infinity, then the function itself is, of course, going to go down because the function is going to head in that direction. And kids will always ask me, well, what's going on in between? Why are we not talking about that? Everything in between is going to be talked about in upcoming sections, but in this one, all it's asking for is long-run behavior. So this just wants to know at the ends, as the x's get exclusively large and exclusively tiny, what does the function do? So these were both even. So if they're even, they go in the same direction. So when I change it and I'm talking about odd, then obviously they're not going to do the same thing. So in this case, we are thinking about x cubed. So I know that x cubed has stuff in the middle, but I know that at the ends they go in opposite directions. So if I have an odd degree and my leading coefficient is positive, then I have that my x's are going to go off this way, my y's are going to go down to negative infinity. And that's how we write that. As x is going to go to negative infinity, f of x is, in this case, going to go to negative infinity. Okay? And then as my x's go off toward positive infinity, this goes up. So this is going to go toward positive infinity. So my x's are getting exclusively large, and then I have that my y's are going to do the same. Now that's if my leading coefficient is positive. So last but not least, we have odd degree and leading coefficient is negative. So if you can think of a negative x cubed, that obviously is going to reflect it over the x-axis. So in this case, my x's are going this way, then my y's are going to be going up and up and up toward positive infinity. So x is going very small. My y values continue to get bigger and bigger. So they go toward infinity. And then in this direction, as x goes toward positive infinity. So my x's are getting extremely large. Then my y values this time are going down toward negative infinity. So as my x's go larger and larger, in this case, my y values are going to get smaller and smaller. So as we start to look at an example of this, I'm looking at f of x is equal to x to the 6th power. So one decision you have to make is whether it's even or odd. So this one's even, so they're going to go in the same direction, meaning they'll either both go up or both go down. Now, this next thing you need to do is your leading coefficient. So this is the number 1 understood to be right there. So that is greater than 0. So that means that they go up and up. And again, as we start to write this down, what we have to acknowledge is that we have to write it properly. So I'm going to color code this. So x's, as x is going to negative infinity, then this y value is going up and up and up to positive infinity. So f of x, or y, goes to positive infinity. And then if we go x is approaching positive infinity on the other side, then your y value again is going up. So f of x is also going to the positive infinity direction. All right, so let's go across. So we have f of x is equal to negative x to the 4th. So again, I'm making those two determinations. So I have that it's an even function. All right, the degree of it is even. So we have to be going in the same direction. And then this time my leading coefficient is negative. Now that means that these are going to go down and down. So again, as we look at this, we're going as x goes to negative infinity. This time my function itself is going in this direction. The y values get smaller and smaller and smaller because they are approaching negative infinity. All right. And then when we look at the other, we have as x is approaching positive infinity this time, your y values again are going down, so that f of x is also approaching negative infinity on this side. When they are even, they go in the same direction. All right, so these bottom two here, we have that we are looking at an odd degree, so they go in opposite. That's easy to remember because they both start with O, okay? Odd degree, opposite direction. And then my leading coefficient right here is a positive number. So this is very similar to the x cubed. So I know in the parent graph of x cubed that this side goes down and the right side goes up. So as we look at this, we have x's are going this way. So as x approaches negative infinity, the y values are going down this way toward negative infinity. So f of x would be going to negative infinity. So if we start going again, going in this direction, we have x is approaching positive infinity this time. And this time we have our y values are going up. So f of x is approaching positive infinity. And then last but not least over here we have the negative x to the 11th. So again we have odd, so O opposite. So these are going to go in opposite direction. And since this leading coefficient is negative this time, think of this as a reflection of x cubed. So it would go here and here. So as x is going off this way, x is going to negative infinity. My function is going up and up and up to positive infinity. So f of x is approaching positive infinity. And then as x is going to negative infinity, positive infinity on this side, then the y values over here are going down. So they go toward negative infinity. So as you're working through these, my encouragement is that you would diagram just a small diagram to see what's going on. All right. So the last one of these we're going to do looks like this. Now, the four that I just did are very straightforward. They only had one term. They only have one thing you had to look at. So just because I've added more to this, as long as it's in descending order, all of these really don't matter when I talk about end behavior. So in this case, I'm looking at a degree of 8, which is even. And if they're even, then they go in the same direction. And this leading coefficient is a positive 4, so that's greater than 0. So if it's even and your leading coefficient is positive, then we are going to end up having the same direction, and it would be up. So as we write this, we are looking at when x goes this way, y goes this way, and as x goes this way, again, y goes this way. So to write that down, we have x is approaching negative infinity, going over to the left. The y value, or f of x, is approaching positive infinity, because this over here is negative infinity, and this would be positive infinity. So on the other side, this is infinity. So over here, as x is approaching positive infinity, and my x's are getting very, very large, then f of x is approaching positive infinity. In addition to what you've already done, they're going to give you a couple of graphs to look at. And in this graph, they want you to tell whether you are talking about a polynomial and what the degree would be. So in this case, we can look at this and tell that the least possible degree that this could possibly be is a 2. Now the reason for that, there's two different reasons. One is that it hits the axis 2 times, and this keeps going down, so end behavior is going in the same direction. Alternatively, you can think about the fact that you have one turning point up here. So remember that if you add 1 to the number of turning points, that will give you the least degree possible. So in this one, what's the least degree possible for this? So we have this diagram, and this is all that's given to you online. So what I'm going to say is that this goes up, and it must hit something up there, and it keeps going. Now, this is going in this direction, this is going in this direction. So right there, I know that this is an odd degree because they are not going in the same direction. Now, as far as looking at your x-intercepts, I can only see one right here, but I know this is not a first degree because it's not a line. So now we have to go back and say, well, okay, how many turning points? So I have one right here, a second there, a third there, and a fourth there. So remember, if I have 4 turning points, I add 1 to that to figure out what my degree is. Okay, again, I have 4 turning points on this. I add 1 to it, so that tells me that I am a 5th degree. The last example they ask you about is that they give you a P of n function, and it's in factored form for you, which is nice. That actually makes life a little easier. And it's asking you to find 2 different things. So your p-intercepts, all right, so, and then n-intercepts. So I'm going to write this, and you could have it looking like this. So this is just x's and y's. So when I start changing variables, sometimes kids have trouble determining which one it means. So if you'll rewrite it so that you see y's and x's, or f of x and x's, then we have to determine what they're asking for. So if they're asking for a p-intercept, that's going to be the same thing as a y-intercept. So we know that when we are finding a y-intercept, we let x be 0. So in my equation, what I'm given, I'm going to let n be equal to 0, and then I will go and solve for p. So as I do that, I get p is equal to 0 minus 4 times 0 plus 5 times 0 minus 7. So when I do this, and kids like to jump the gun on this, and I'm going to just tell you, slow down just a minute. So if I end up writing that down, then we are less likely to make a mistake. I have a negative times a negative, so it's positive. 4 times 5 is 20, and 20 times 7 would be 140. So that would be my p-intercept. If they want it as an ordered pair point, that would be 0, 140. Now for n-intercepts, that's the same thing as finding an x-intercept. And when I do that, I let y be equal to 0. So in our case, let p of n be equal to 0 and solve for n. Now, the nice thing about this is that it's already in factored form. So I will have 0 is equal to n minus 4 times n plus 5 times n minus 7. So what I do is take each one of those factors and set it equal to 0. So I have n minus 4 is equal to 0, n plus 5 is equal to 0, and n minus 7 is equal to 0. So n is going to hit the x-axis, or n-axis in our case, at 4, at negative 5, and also at positive 7. Again, if they want ordered pair points, you're going to have 4, 0, you're going to have negative 5, 0, and you're going to have 7, 0.